Hey, hi YouTube, how are you? I hope you all guys are doing great. Till now, we have seen introduction to pandas, data reading and writing, and currently in this video, we are going to see data cleaning and transformation. So let's move to data cleaning and transformation. And definitely, in this video, we are not going to see all the different techniques of data cleaning and transformation because I don't like that way. Instead, what we can do is we can take a use case where we will be having a CSV and we will act like we are a data engineer or data scientist, and how they perform the data cleaning and transformation, we are going trying to mimic it as a beginner level. Okay, so I think that's the better way instead of mugging up all the methods and all, and then at the end you are clueless where to apply it. Okay, so instead we will try to take a use case where we will be having a CSV. Okay, so we will be having a CSV. First of all, we will try to see how actually a data engineers look up when he got a CSV or the data in packet format or any other kind of format. Okay, then once he look up, then we have to understand like business analysis, or you can say maybe as of now I should not use this word, or maybe understanding the data. Okay, because once you look up the data, you have to understanding the data, because maybe you are not knowing anything about medicines and your CSV is having, let's suppose, hundreds columns with different terminologies of medicines and all, and you don't know about it. So you will go to a business owner or who is having some information about the data. You can ask him, okay, what this column represent, what this column represent and all, because understanding the data is very, very important, because each column is called as feature. So maybe from that feature you will get an idea how to handle the missing value, or how you can handle basically how you can handle null values, or how you can drive some new features or kind of thing. Okay, so understanding of data is really, really important, because in general it's not, basically in the example that we are going to understand, we are going to take very simple CSV, but when you see the real data where there are more than 100 columns in an CSV or Excel that you are getting, and if you are not able to understand what each column means, then you will never become a good feature engineer or a good data engineer, because you cannot provide to a model um, um, like non-useful information, or you cannot drop a useful information. Okay, so understanding the data is really, really important. Once you understand the data, okay, so let's suppose you understood the data and everything is done, then you have to handle the missing values, because uh, wherever you are trying to let's suppose you want to give your data to an ML model, or you want to give some ML engineers to train model on this data, then definitely you are never supposed to give missing values. So you have to handle this missing values. Okay. Once we handle the missing values, then we can have like handling edge cases. So you can handle some edge cases also. Okay, I will explain you what actually edge cases means, and at the end you can do feature engineering. Okay, so what actually feature engineering is, like if I want to give you an example, so let's suppose you have one feature or one column as date of joining, and you want to find that how many years since the employer is working on my company. Then definitely what you will do, you will take that date of joining column and you will subtract it from current date. So current date minus that particular date of joining or year of joining. So you will get the number of years on which since when the particular employee is working on your company. So it can be really important feature, but that feature was not in your original data. You have derived it. So that kind of thing we do in the feature engineering. And there is also a field called EDA, if you might have heard about it, which is called exploratory data analysis. So whenever you get a CSV, or whenever you get a data in any kind of format, then you have to first look up the data, understanding the data, then handle the missing values, handle the edge cases and feature engineering. Now, why we are doing all these things? Because we want some good data. Okay, because good data can leads to better model training, or you want some insights, because um, if you are running a business, then all the things which matter is the insights. Because let's suppose you are having a huge data and you are clueless what to use, then the data scientist might give some insights on it. Let's suppose you are having transportation data, then what the business owner wants to hear from you, like What is the optimal cost on which passenger is willing to pay? Maybe in the bracket of $5 to $7. So it's better to keep that price between say $5 to $7, not more than that, no, not less than that, because it should be good for both. It should be a win-win situation for both customers as well as the people who are driving the taxi and also for the business. In the same way, they what can be a good useful insights for them, like on which what is the peak hour of cab. So this kind of insightful things they need from data engineer, data scientist, and all ML engineer and all. Okay, but as a data engineer, you want to try to um, clean the data as much as you can and handle the missing values, handle the edge cases, and also some feature engineering. Okay, so first we have to like look up the data. So let's see how we can look up the data. So in the previous video, we have seen how we can read, how we can actually read the data and how we can write the data. So in this video, we are going to see how we can clean. It will be the heading. I can put it as data cleaning and transformation. Data cleaning and transformation. Okay, so this will be our heading. Okay, inside which I will put each and everything. So first part is we have to look up. Okay, so how we look up the data, or maybe I can say load and look up the data. So load and look up the data. So in previous video only I have explained you how we can load the data. So here you can see we have the data which is data.csv. Okay, in the collab. So pd dot read csv, and we can pass the csv data.csv. So it will load and it will load it into a data frame. Now, if you want to look up the data, so first look up data, how you can look up the data, like if you got a CSV and you want to see like how many rows and columns are there. So you can do df.shape. So it will give you, sorry, it's an object. So df.shape. So you will get like, okay, I have 8 rows and 7 columns. Okay. Then maybe you want to see some informations of that data frame. So you can do df.info. So here you can see we got a data frame and we have 8 entries 0 to 7. The index is 0 to 7, and there is a name column which is having 7 non-null values. We have 8 rows. Here you can see we have 8 rows, and out of 8 we have 7 non-null values, means we have one null value. So it is also important that to understand like, okay, how many null values we have. Like if there is a column which is having, let's suppose, more than 50 null values or more than 70% null values are there, then definitely it's a better idea to drop that column. Okay, to drop that feature. Like if you see the salary, so here we have 6 non-null values. So it means that there are 2 columns, 2 rows, which is having null values, okay, in the salary column. Then the type also, which we call data type. So data type of team is object, because the string is treated as object. Then age is float 64, gender is object, salary is float 64, and all. Then we have performance score and all things. So currently total we have 3 float type of data type, like we have 3 numeric data type and 4 object data type, okay, which is string. Okay, and also we have memory users. But let's suppose you want something as a statistical summary. So what you can do, df dot describe. Okay, so df dot describe basically gives us a statistical summary. So statistical summary will only work on the numerical column, because you cannot find average and mean, mode, median for uh, like non-numerical columns, because numerical columns can only have their maximum, minimum, and all. Okay, so here you can see if we describe it. So for age is a numerical column, so it will give us the count, mean, standard deviation, minimum value, percentile, and maximum value. Okay, also for salary and performance. Now we have done with describe. Now if you want to see like how many null values I have in all the columns, so what I can do is df is null dot sum. So this will basically give me, because we have done the sum also, so it will give us the how many null values we have in the each column. So in name we have 1 null values, in age we have 1 null value, in salary we have 2 null values, in performance score we have 1 null value. Now if you want to see the data, in the previous video only I have explained you, like let's suppose let's do 10, maybe we want to see the top 10 rows. In our CSV, it's a very small CSV. We don't have 10 rows, we just have 8 rows. So that's why we are seeing the first 8 rows. So let's see, confirm it. So in salary, we have two null values. So here you can see we have two null values in the salary column. Okay. So this is how you can look up the data. Okay, this is the way to look up the data. Now let's try to understand the business, or let's try to understand the second step was understanding the data. So let's try to understand the data. So we have seen we have multiple columns, like one column was name, one column was age, one column was gender, one column was salary, one column was city, one column was one column was city, then we have one column was joining date, and we have also performance score. Now, because why I'm trying to make this exercise, because understanding the columns are really, really important. As I have given you the example that maybe if there are more than 100 columns and it's in a different language or it's out of your domain, because if you are working on retail domain and suddenly you got the data of healthcare department or any automobile department, that will be very hard to understand the column just by reading the column name. Okay, in real life it doesn't work like that. Okay, so you have to understand. So the business owner will explain you that okay, this is the name of the customer, age, gender, salary of the employee, city where he is living or where he is working, then joining date, and the performance score. Now, okay. So once you see this, then you might think like, okay, after taking some time, you might mark it as this is my main thing, performance score. This is my KPI. Okay, either the business owner will explain you this is our KPI. KPI means key performance indicator, means which is the main thing. So in this case, it is the performance score is the main thing, because based on the performance score, you can put the employee into a category like gold, silver, bronze, or maybe you can decide their salaries on the performance score and all. So performance score is really, really important. So now, so this is all what you can derive. Okay. Now, the second part is how to handle the missing value. Okay. So now let's see. Name is basically name is basically string or object. You can say I'm writing it as a string. Age is number. Gender is basically categorical. Okay, categorical means what can be the different values for gender: male, female, transgender, and other. So it's a category. Okay, there can be uh, no other values. Then for salary, it's sorry, sorry. What I have written here, even I am not able to read it. Okay. So this is number. Okay, numerical. So this is numerical, 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 numerical. Categorical. We have this as numerical. City is also categorical. Let's suppose we have 6 to 5 cities. Okay. Then job description, sorry, sorry, JD is joining date. Its data type is date, and which we also call it as object, or maybe let's suppose in this case it is a string only. Okay, it's not. Let's suppose it's not in date format. If you let's see, if you see it here, the data type. If you here, so the data type is object only. Okay, cool. Then performance score is basically numerical. Okay. Now, why I have written this? Because this is really, really important to handle the missing values. Now, there are different ways to handle numerical missing values, and there are also different ways to handle the categorical missing values. But in this case, as we are taking a use case, and for this use case, any like let's suppose we can take any one way to handle the missing categorical values and missing numerical values. There are lots of different ways also. Okay, so don't worry about it. Okay, we can cover it in some different use case. So let's suppose we have numerical. Okay, so to handle this numerical um, missing values, we can take median. Okay, so we will take median. If you don't know about median, so median is basically, you can say, the middle value in a set of numbers when the numbers are ordered from smallest to largest. Okay, in cat and in the categorical we are going to take, let's suppose, mode. Okay, so in categorical we are going to take the mode. What is mode? The number that appears most frequently in a set of numbers. Okay, then maybe if the joining date is um, null, we can add unknown. Okay, simple. Now you may ask me that, okay, uh, this is this this was numerical. Change color to something else. Okay, it will be much better if I take this color. Okay, so you might ask me, okay, why you didn't handle this? Okay, because maybe you can add, if it is a string, you can add some unknown values, or the performance score is numerical, so maybe you can add some median. But it's not like that. See, performance score is our KPI. It means that if some user is there who is not having any performance indicator, and now I am adding his performance indicator, it can be anything. Like maybe on the scale of 10, I am adding 8. So it's not good because the person is not having any performance score. He's not performing, and we are adding some performance score on which his salary, his category, and all things are dependent. So it's not good thing. Okay. In the similar way, if in name, if someone is not having name, how we can fill it name? So if these two values are null, then directly we are going to delete this row. So if we are having 10 rows, and out of 10 rows, let's suppose one row is there which is having no name, we are going to delete it. If there is one row which is having no performance score, we are going to delete it. Okay. So this is how we are going to handle the null values. Okay, so now let's move to the screen where we are going to do the practical. So this we have done the business analysis. So business analysis and done. Okay, and also in business analysis, outlier analysis is also a part where you see the outliers, but it needs some info, understanding of matplotlib. So currently, I don't want again to move into matplotlib, and like I am trying to put your main focus on only on pandas. So okay. So handling the missing values. Okay. But before moving to it, what I want is mm, 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 okay. See, if you see this data now, sometimes we also have, instead of NaN, we also have something like this, n/a. I've seen in some data set. So it's not a good practice. Instead, we should have this NaN values, which is like defined in NumPy. Okay. So if you don't know about NumPy, it's also a library for which we call as numerical Python. So to handle the numerical values and to deal with big numerical values. So there are some instances where we see this kind of n/a. So first of all, because we can't see all the rows, there are millions of rows. So we predicted something like we have some practices. Okay, so what we can do is like df dot replace, and maybe we can just replace the na n/a, sorry, n/a with np. What is np? So np is basically numpy, so we have to import it. Okay, so import numpy as np. Okay, just don't focus a lot if you don't know about numpy. Numpy dot nan. Okay, so it provides an object as nan. Then in place is equal to true. In place is equal to true. It means that in the same data frame you want to change it. Okay, if you don't want it, maybe you can do like this. So this will now give you a data frame. Okay, and now you have to, this will give you a data frame. Now you have to store this result into another data frame. Okay, this is also good, or either you can do in place as true also. Okay, so let me do it. So now we have replaced all the places. If we have some string like this to np.nan. Basically, this is a way to standardization, okay, which we call it as standardization. Okay, so we are going to do standardization. Simple. Okay. Oh, sorry. Okay. Now let's start the real journey of how to handle the missing values. And first will be handling numerical columns. So we have decided that in numerical columns we are going to take the median. Okay, you can also take mean or whatever you want. Okay, so first column, which is the numerical column, it was, if you can see it, it was salary. Okay, so df salary dot fill na. Okay, fill na. So what you want to fill? Maybe 500, 600? No, I don't. It can be 600, 700. No, because I don't have a specific value. I want the median of that salary column. First, you need to access the column. So it is basically salary. My column name is salary. Okay. I want the median of it. So median. Okay. So I want the median. I want it to fill it with that. And I don't want to like create I don't want to store it in the another data frame. Instead, what I want to do is I want to do it as in place. Okay. I want to directly change this data frame. Okay. So this is one of the way. So if I run it, so maybe it's throwing an error. It's not an error, it's an warning. It's saying that let's read it. A value is trying to be set on a copy of a data frame or a series through chained assignment using an in-place method. This behavior will change in Pandas 3.0. Okay, this in-place method will never work because the intermediate object on which we are setting values always behave as copy. Okay, so if you see, okay, so if let's do something as pip freeze. Okay, maybe pip freeze, and here you can see whatever libraries we have installed. So if we see it here, there should be something as pandas. Okay, so let's try to find pandas. So here we have pandas as 2.2.2. So what the error was saying that in pandas 3, okay, let me delete it. So in pandas 3, we are going to this in place method will never work. Instead, you can do like this or you can do like this. Okay, so let's change it. So I am not going to do in place is equals to true. Instead, what I am going to do is this will return a data frame to me. And now, because I am going to make changes in the salary column only. Okay, so it will be like salary. Okay, because in salary column, I just want to modify it. Okay, so it will be like this. So now if I will see the data frame, okay, data dot, how we see it, data dot head and maybe 10. Okay, so here if you see it now, so in salary column, initially if you see the salary column, there was two NaN values, but we have filled it with some median values. Okay, and now most of the beginners, even I was also doing it like this. This is not good way, okay, because if you do it like this now only salary column will be existing because this df will be only now containing this df salary dot fill na. Okay, instead what we should do, we should only change in the salary column of this df. Instead, if we just do df, okay, what we actually we are doing, so we are taking this salary column and we are filling it with median and we are returning it. So we are just playing in this only one column, and the one column we are going to store in this df, which we don't want. We want the whole thing. Okay, so that's why instead of directly going to this changing the data frame, we just go to this salary column and change it. Okay, I think you are getting it. Okay, so I have messed up now. So now I have to again go from read. Okay, so maybe there should be some functionality runtime run cell and below. Okay, so I have to first read it and all the cells which are below this I have to run it. So now you can see that we again got the data. Okay, so this is how we have handled the median value, the salary point. Okay, now there is one more numerical column. So let me just add it like this. So which was age. So I think now it's very easy. So again for age, and we will make it something like this, age and age. So I think I don't have to explain this because it's same kind of that we have done in salary. If I will run it, so this is the old data. So here you can see in the age we have some null values. So now it will be covered with median. So if you run it, so here you can see the age which was having null, now it is having a median value. Okay. So let me just cut it and let me add it here so that it better for track. If you want the code, I can provide you. Okay, that's it. So this was how we can handle the numerical columns. Now, how to handling the categorical columns. Okay, how we can handle the categorical columns. So what were the categorical columns we had? One was gender, and then we have the city. Okay, so df, let's suppose that's suggesting me, but I'm not going to use it as of now. So it was gender. Okay, here you can see gender. In this we are going to just focus on gender. Okay, so df gender. Now wherever you are going to see null values, fill na, you have to fill it with some value. But what is the value? We don't know. Okay, we have to use it. Okay, so we cannot directly say fill it with male female. Okay, because in gender we know that it is male female, but when you will have a different column which whose value, whose category you are unknown, because there are millions of rows. Okay, you can't put any one random value. So you want the mode of it. So directly we can take, okay, df, the column name for us is gender, and we want the mode of it. Okay, so we want the mode of it and the zeroth index of it. Okay, so the zeroth index of it. Okay. Okay, now if you haven't understood, okay, it should be in string format, isn't it? Okay, should be format. Okay, if you haven't understood what this we are doing at the zeroth index, basically it returns a series. Okay, so the highest occurring will be at the top, then the second highest, and so on. So it will return a series. And if you don't know about series, it's kind of a 1D array, which I have also covered in the first video. If you have not seen the video, could just go and watch it. It returns a series. Basically it's a list. So we have to take the most occurring thing. Okay, that's the mode. So that's why we take at the zeroth index. Okay, and again, if you don't want to this part, then you can do in place is equals to true. But as we have seen, it was throwing an error, so we can just go with it. Okay, it should not be df. Okay, it should be df gender, because we just want to change the gender column. Okay, nothing else. In the similar way, we are also going to do for I think we were having city as our categorical column, isn't it? So we are going to do the same with city also. City. Okay. City. It's better practice to copy paste. Okay, because lots of time the column names are very very huge. Okay, let me run it. Okay, and now again let me print it. So this was the old data where we were having some NA values in fourth row. Sorry, it's fifth row, fourth index, and all. So let me just show to you. So in city, now you can see it was replaced with Chicago. Why? Because Chicago was appearing more like two times, so it was filled with Chicago. Maybe it can be also filled with New York, because New York also was appearing two times. In the same way, for gender. Okay, so in gender, this was the place which was having NAN. So NAN was fourth, and now it has been filled with female. Okay, so because female is occurring three times and male is occurring also three times, so it's just a coincidence, because if we have more as a male, then it should be filled with male. Okay, but now it's for the tie, so it can be any one of them. Okay, so let me just move forward, and we were also thinking what else we were thinking. So we have to also handle the joining date with unknown. Okay, so now if we have joining date, if we don't have any joining date, we are going to fill it with unknown. Okay, so df, and the column name was, sorry, it was joining date. Let me copy paste it, because there is a high chance that I will make some mistake. So df joining date, and df joining date, and it will be fill na, and we are going to fill it with unknown value. Okay, so unknown. Okay, and definitely we are not going to do in place is equals to true, because we are storing it into a data frame. Okay, so let me run it once. Okay, so here you can see in the joining date there was a nan. Okay, so now again, if I will do df dot head, so I'm just writing it again and again to show you so that you can have a better understanding. So wherever there was no date, which was in the fourth row, so we were replacing it with the fourth index was replaced with unknown. Okay. Now we have also we were also saying, okay, so this was handling the categorical columns, handle, we can say customize, or we can say handling handling columns, customized columns, we can say, okay, in a customized manner, maybe in a customized manner, maybe we can say, okay, so we are adding unknown here. Okay. Okay, my MacBook is on low battery. Okay. Now we have also seen that there were two columns, like one was name and performance score. If this are null, then we are going to delete that rows. Okay. So it is drop missing values. Okay. This is also important. So we can directly drop it. Okay, drop na, so it will df dot drop na in place is equal to true means wherever there is null value you have to drop, but we don't generally use it. Okay, because it's not a good practice that directly wherever there is null you are going to replace it. Instead you should try to fill it with like this using mean mode median. Okay, because whatever columns or whatever rows you are trying to delete, maybe like suppose in salary it is null, but maybe that will be not an important column. The performance score is important column, and we are having performance score for that particular employee. Okay, out of 100 rows only, out of 100 columns, only one column is null, and it's not also important, and you are deleting the whole row. It's a loss of data. So it's very important to understand the data and where we have to drop it. Okay, so df drop na, and there is also something as subset. Okay, so this is what I want to show you. So now the subset here we will add performance score. Okay, the subset will be performance score. Okay, so now it will look into performance score only the column of performance score. If we just do drop na, it will look to the whole data frame. Instead, now df dot drop na means it will just look at the performance score column, and if it contains a null value it will delete that particular row. So here you can see in the sixth, which was Grace, his name was Grace, was having something as performance score as NAN as null, so we have to handle it. Either we can, let's try in place equals to true. Okay, so I know it might throw a warning, but now it doesn't throw a warning. But it's not a good practice to use in place because sometimes we even don't know what we are doing. Okay, so we should not lose the data. Okay, so here you can see the Grace is now gone. Okay, so Eva, Nan, and Henry. Okay, so Grace is gone. Okay, the same thing we have to also perform on this name, because we came to a agreement that if the name column is also empty, then we have to remove that row. Okay, so name. Okay, so let me run it and let me give it a run. So now there should not be any name which is NAN. Okay, so we have Alice, Bob, Charlie, Alice, Bob, Charlie, David, Eva, Henry. Okay, why Grace was gone? Because the performance score was null, and why this fifth index was gone? Because name was null. And we have decided that okay, name and performance score, we don't want it as null. Okay, so we are done. Okay, so we have done some data cleaning. Okay, I think data cleaning is now done, so let's go. What was the way how we can tell how many null values we have in each column? Tell me quickly. Just pause this video and tell me quickly. So it was is null dot sum. Okay, so is null, it's also a function, is null dot sum. So now here we can say in each column we don't have any null values, 0 0 0. Okay, so we have sorry, we have done lots of changes here. We have handled all the missing values for numerical, categorical, as well as for whatever data we have to, if we have to drop some missing values. Okay, so basically this is the way how we handle the missing values. Now the next thing was, if you go to this screen, the next so we have done lookup to the data. sorry, power on it. Look up the data, understanding the data, handling missing values. Now we have to handle the edge cases. So how we actually handle the edge cases? So now directly I can show you. This is not very, very important, but let me show it to you. Okay. So handling the edge cases. Handling the edge, or maybe in the code only I should add a comment only. Okay. So handling the the edge cases. Okay. So let's suppose a name, okay. Maybe there are some white spaces or leading or trailing white spaces. We don't want it. Okay, so what you can do, simply what you can do, df name, df, sorry, n is capital, df name is equals to df. In which column we want to perform df name? Okay, df name, and we want to we call it as a strip. Okay, in Python, if you are familiar with Python, we use a function as a strip. Strip is basically so it's removed leading and trailing spaces. What I mean is simple. Okay, so let's suppose there is a name called Jacob. Okay, and there are some spaces here or maybe at the end, but we don't want it. We just want Jacob. Okay, so we don't want any. Maybe I can add like this so it will be much clear to you. So here you can see there are some leading spaces as well as some trailing spaces, but I don't want like this. I want the string to be like this, Jacob. Okay, so there should not be any leading spaces and not also the trailing spaces. Okay, so that's why I am work making it like this. Oh, what is happening? Come on. Okay, so we have to do strip. But before doing strip, as strip is inside, it is a string method. Okay, if you are familiar with Python, then strip is basically a string method. So we have to do dot str and dot strip. Okay, so now it will remove all the leading and trailing spaces. Okay, so now let's again do it df dot head. Okay, so df dot head. So we don't have to do df dot head again and again. So if there are some leading and trailing spaces, it will remove it. Okay, it doesn't have any leading and trailing spaces, so it's fine. Okay, now in the similar way, there are some more methods. So maybe df, uh, sorry, df city. Okay, you can also do. It's not like you have to do single quotes. You can do also double quotes. It's fine. Okay, I just prefer single quotes. Okay. So DF and maybe in city only. Again, here also maybe there are some places like here you can see. Okay, so there is dash. Okay, I'm just now giving some imaginary use cases. Okay, like you don't want this dash, you want Los Angeles. So what you can do again, you can use some replace function from Python replace, and you want to replace this dash with space. Okay, wherever there is dash, you want to replace it space. Okay, as simple as that. Okay, why we have done str, because replace is also a string function. Okay, it is a string method. Okay, let me show it again. All together I will show you. So now in gender, let's suppose in gender, what we can do. Okay, so in gender you can see that there is m, because lot of time m is also considered male. Okay, so what, see, this is also a type of you can say, maybe if you want all the gender to be in uppercase, then you can do str dot upper. Okay, but currently we don't want it. So df uh, gender, and we want to replace it with not we are not going to use str. Now we can directly use replace. Okay, so replace and replace the mm, m with male. Okay, so we wanted something like this. We want to replace all the m with male. Okay, we want to replace all the m with male. Okay, cool. So let me give it a run and run it. So now see, previously there was M here, so it has been replaced with male, and we were having Los Des Angeles, so now it will be converted into Los Angeles. Okay, as simple as that. Okay, So you can also add in this dictionary comma for mf for female and all. Okay. So now I think you might have a question like, what is the difference between these two replace? Okay. So the first replace for that we have used for city, it's a string method, and whenever we have replace in a string method, it is used to replace substring or patterns. So actually, it will not replace the whole string, because here you can see this dash is basically a substring. Okay, this dash is just a substring. We don't have to replace the whole string. Okay, so otherwise, if we just use replace, this replace, it looks for m, the whole data. So here you can see the whole string was just m, so it was replacing with male. Okay, but if we want to replace with substrings, then we have to use this str dot replace, because whenever you see the replace method of string, okay, then it replaces the substring or pattern. But if you directly use this replace, which is of data frame, which is a data frame method, so which is replace try used to replace the entire value. Okay, you have to use a mapping like this dictionary. Okay, I think you have understood. Okay, the difference. Now we have also done with handling the edge cases. Now we have to do some feature engineering. Okay, it's not okay. So now we are going to see the feature engineering part. So basically, feature engineering itself is a very vast thing, but currently we just want to derive a feature based on this joining date, and the feature that we want to derive is year since joining. So how we can find year since joining? So this date, we have to extract the year from this date and subtract from current date. So okay, but first let's see print df dot d type. Okay, so basically this will give you the d types. So what are the data types? So here we can see that joining date is an object which is a string. Okay, so first of all we have to convert this joining date into like date time format. Okay, not as a string, because we have to extract the year, and from a string how we can do it. Okay, so let's do it. Df, the column that we want to convert it into a specific data type. So df joining date is equals to um, maybe what we can do is pd, this one, pd dot to data time, and which column we want to convert it into data time, which is joining date. Okay, please don't do like this df is equals to, otherwise only it will store the joining data, nothing else. Okay, so I can do shift and enter, so it will work. Okay, so it is saying something here. Okay. Mm-mm-mm. Time data unknown doesn't match, format this at position number 4 you want to try. Okay, so this was also I want to show you that. Okay, if you do like this, okay, so what actually the problem is, if you see here there is an unknown thing. Okay, so if there is something as unknown, then how it will be converting it into um, you can say date and time. So here what we add is we add a field as errors as course. Okay, so now if we will run it, it will be done successfully. Okay, and let's try to see what actually happened. So if I run it now, so what it actually does is if you add as errors is equals to course, it means that it will replace invalid dates with NAT, which is not a time. Okay, and similarly, if I will do print df dot d types now, what will happen? Let's see. So if we now see the data type, the joining date is now date time. Okay, it's not an object. Now we can perform all the date operations here. Okay, so now the real feature engineering will start, and we will create a new column, and let's suppose the name of the column is years since joining, maybe years since joining. Okay, years since joining. Okay, and we want to get the current data, current date. So 2 underscore date time. Okay, 2 underscore date time, and the current date and time for today. And we just want year, because the current year minus the joining year. Okay, so then subtract df, then we actually want this joining date. So let me copy it here, df joining date, and we want the year of it. So it will be dt dot year. Okay, cool. So now if I will again do df head and I want to see the first 10 rows. So here you can see, I'm just showing it again and again just to show you, okay, there is nothing else. So you in real you don't have to keep seeing this data, okay, because every transaction will cost you. Okay, so here you can see year since joining 5, 6, 7, NAN because it was not a time. Okay, so this is how it works. Okay, now what actually details. So similarly here we have seen str. So whenever we have to use a strip, it's a string method. So we have to do a dot str. If here replace is a string method, so it's a dot str. Similarly, the dot here is a you can say date specific attribute. So we have to do dt dot year. Okay, so we have created a feature which is year since joining. In the initial data set, there was no column or no feature as year since joining, but we have derived it. So this is called feature engineering. So we have created a feature based on joining date, which may be important, like if you want to give some incentives, or maybe you want to give some bonus to the people who are in your company like more than 5 years. So this all rows will get some incentives. So basically this kind of features can be important. So this is also a work of data engineer to think in such directions. Okay, so we have done lots of things today. Data cleaning and transformation, where we have look up the data, understand the data. Then we have also handled the missing values. We have handled the edge cases, and also we have done a bit feature engineering. Okay, with a simple use case. Maybe in future videos, if you want more use case, we can cover more use case, and we can use different techniques. Like currently, we have used median to handle the numerical data. Maybe we can use mean, or we can use some different techniques. There are a lot of other techniques. For categorical, there is mode. Maybe we can use some fixed value, or maybe we can use some different techniques. Okay, and so I think when we study from use case, in my personal experience, we learn a lot of things, and it gives us a more interest. It brings some interest in that part. So that's why I prefer this use case instead. Teaching all the ways of handling null value for numerical, then for categorical and all. Instead, it's a good way to have a basic use case, and then we can move and explore different ways to handle numerical, categorical, and other types of you can say data. Okay, so because if you once you get the interest, you can directly go in Google and search, okay, how to handle numerical missing values. Okay, because now your interest is there. Okay, I got a use case, and I solved a use case, and now if I have another use case, how I can handle it. So that's why understanding with an example and use case is the best way, I think. Okay, so meet you in the next video, where we will be seeing data, maybe another use case of data cleaning and transformation if you want, or otherwise we will see advanced manipulation. That is also very, very important. Okay, so that's all. Meet you in the next video. Till then, bye bye. Thank you.